Assalamualaikum warahmatullahi wabarakatuh. Today, we group want to present about an X-ray. What actually is X-ray? First I want to introduce you with my team. We have Muhammad Afif Aiman bin Azhar, Muhammad Nurman bin Muhammad Isnin, dan for myself Mukri Shafi bin Zulkifli. X-ray. The definition of X-ray. X-ray is just like any other kind of electromagnetic radiation. They can be produced in packets of energy called photon, just like light. There are two different atomic processes that can produce X-ray photon. One called Bremsstrahlung, a German term meaning breaking radiation, and other called K-shell emission. They both can occur in heavy atom of tungsten, which is often the material chosen for the target or anode of the X-ray tube. So project goal. Our goal is to increase self-awareness toward an X-rays, and second is increase social responsibilities toward X-rays. Introduction. Discovery of production of X-ray. It is found by Wilhelm Conrad Röntgen. He discovered when electrons were accelerated by a high voltage in a vacuum tube and allowed to strike a glass or metal surface inside the tube. And the fluorescent mineral some distance away will glow and photographic film will become exposed. This produces a new type of radiation which called X-ray. When charged particles collide, they produce bundles of energy called photons that fly away from the scene and accident at the speed of light. It occurs in very high temperatures, millions of degrees Celsius, to produce X-ray. So this is an example. Bertha's, which is Wilhelm wife, and hand with ring. So next is production of an X-ray. So production of an X-ray is electrical current move through the tungsten filament, causing it to glow and emit electron. So a large voltage difference is placed between cathode and anode, and it causes the electron to move at high velocity from the filament to the anode target. Number 2, when atom strikes in the target, the electron displaces the inner shell electron, resulting in outer shell electron having to jump to a lower energy shell. Then the X-ray move through window can be used to provide information. So qualitative study of production of an X-ray. First, medical is to destroy the cancer cells, to investigate organs in the body, and also track the broken bone. Mainly we use X-ray for broken bone. In general is to check good luggage and luggage at the airport. This is another common thing to use an X-ray for. And industry is to check the defect in machine or engine, to check the cracks in structure of plastic. And lastly, last but not least, is research to study the crystal structures and separation distance of an atom. So that's all from me, and my groupmate will continue it. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Isnin. So for this part, I will continue with continuous of X-ray spectra. So for the definition is, when the target material of the X-ray tube is bombarded with electron accelerated from the cathode filament, two types of X-ray spectra are produced. So this continuous X-ray spectra consists of range wavelength of X-ray with minimum wavelength and intensity. Intensity increases when the voltage increases. So for the easiest way to see is you can use both model of the atom, and each of these electronic transition produce an X-ray with a wavelength that depends on the exact structure of the atom being bombarded. as you can see here, this is the continuous X-ray spectrum emits from a tungsten target for 4 different value of EV, the incident electron energy. Next, for the characteristic X-ray spectra, it produces at high voltage as the result of specific electronic transition that take place within individual atoms of the target material. At the left side, you can see the image of the tube current and the degree by which the applied voltage exceeds the critical excitation voltage for that line determine the intensity of any characteristic line. And then at the right side, you can see the image of the characteristic spectra have very narrow line. Most of them were less than 0.01 ampere watt, full width is at half maximum. And then the K line, the narrow and high intensity, make X-ray diffraction possible since it generally requires to use monochromatic radiation. Next is diffraction of X-ray. It is the light bands around object it passes and spreads out after passing through. So for the first one is constructive interference, which is occur when the maxima of two waves and together in the same phase, so that the amplitude of the resulting wave is equal to the sum of individual amplitudes. And then for the destructive interference, it is occur when the maxima of two waves are 180 degrees out of phase. At the left side, it is the image of the constructive interference, and the right side is the image of destructive interference. So next we go through for the law of X-ray.
Yeah, Assalamualaikum, and my name is Muhammad Afif-Aiman bin Azhar, and I will continue to explain about the Bragg's law. So what is the Bragg's law? So the Bragg's law is the law states that when the X-ray is incident onto a crystal surface, its angle of incidence will reflect back with the same angle of scattering. It seems like when we use the light go to the window and so on, it will produce the same angle before and after. So what is the formula is n lambda is equal to 2 dc theta. So what is lambda? Lambda is a wavelength of X-ray. Theta is the angle between the incident rays and the surface. And d, what is t? D is spacing between layers of an atom. So as we can see, there is an arrow to show to us about the same angle before and after. Okay, now I will consider about the Moseley's law, which is produced at 1887 to 1915. So Moseley's law describes the relationship between atomic number and the wavelength of a spectral line. So wavelength of a specific line decreases as the atomic number of the emitter increases. So the square root of the line frequencies V and the atomic number Z have a linear relationship. So linear means when the other side increases, the other side also increases. So as you guys can see, there is a table about that, and there is a formula which is, like I said, is known. Since theta is a constant, so lambda is 1.5406. Next is about the radiography testing is the non-destructive testing. So radiography is used in almost every industrial applications such as engineering, forensic and securities. In NDT, radiography is one of the most widely and important used method. In NDT, NDT have plenty advantages over its disadvantages. However, one of its main disadvantages is the health risk associated with the light radiation. Radiographic testing, also known as RT, is used to inspect material for its hidden flaws. Using its short wavelength electromagnetic radiation high energy photons to penetrate various materials. So as we can see, it is a photo of the radiographic testing. Okay, now so we go to the properties of X-rays and gamma rays. So one of the properties is they are hard to detect by human sense, of course. It travels in a straight line, it does not travel in a circular line and the wave line. No, it travels in a straight line, and path cannot be changed by electrical or magnetic field. So now we go to the advantages and disadvantages. The primary advantages and disadvantages of RT as compared to other NDT methods are. So first we will talk about the advantages first. So both can detect surface and internal discontinuous. The next one is both can detect significant variation in composition. have a very few materials limitation, can inspect hidden areas without direct access to surface, need a minimal part of preparation, test record is a permanent, okay, good portability, especially for gamma ray sources. So all of this is the advantages of. Now we'll talk about the disadvantages. Okay, the first disadvantage is risk towards the operators and other nearby personnel, of course. Next one is next to have high degree skills and experience for exposure and interpretation. We cannot hire someone with no knowledge to handle these things. The next is relatively expensive equipment, especially for X-ray sources. It is very expensive, so we need a lot of money to buy that things. Next is the process is generally slow, and the last one is it requires a two-sided access to the components. So all of this is the disadvantages of these things. So here there is a few references that we find to complete all or to find every information of these topics. That's all from us. By the way, thank you Medium for taking our video, and thank you everyone who participated to complete this slide, and thank you.